Thank you. Thank you very much, Justin, and good afternoon, everyone. It's a pleasure being with you. Just quickly, I really want to firstly acknowledge my collaborators in industry and other universities. Mostly, recently publishing a book which is a combination of a collaboration across the academia, government, and industry on the digital twin fundamentals and application, which is, building my career here at the University of Central Florida, where I started teaching the introduction to digital transformation and digital twin, and leading towards the application of that in my area, which is urban analytics. So I start with the challenges on cities, where you see the population of the cities and urbanization is increasing, and by 2050 we are anticipating having around 70% of the population being living in the cities, where we are dealing with the infrastructure, very complex infrastructure development, as well as different sort of populations and natural environments. So these three are building the ecosystem of the cities and urban regions, where we are dealing with changing of the temperature in different parts. Urban heat island, as you can see here, is one of the challenges. And thanks to Melanie to help us to learn this. Urban heat island here, as you can see here, you are actually in downtown area. Normally, because of the buildings, high traffic area, and so on, you normally deal with the higher temperature in cities. Whereas if you go to the countryside, certainly the temperature goes down. This will impact on the energy, the health of the population, and certainly the quality of life. We are dealing with a number of huge amount of traffics and disasters which are building up together. But we have a challenge here from this urban perspective. So you see that the cities are very complex entities dealing with the human nature and built environment. So one major challenge that we are having to reach the urban quality of life or sustainability is the fragmentation of the information. And also, when it comes to the digital twin, which is a digital replication of the cities or any process in the cities, we don't know really what is the level of fidelity of the data or the frequency of that, because while the computational capabilities are increasing, this is a very expensive infrastructure to be able to implement in cities, and there is no very clear answer to the return of investment for the users, like the municipalities or the counties and decision makers. So today, I'm going to talk about the three dimensions here: fragmentation of the data, the level of frequency and fidelity, to be able to address some of these challenges. I start with one case that we just recently delivered for the Open Geospatial Consortium, and this is a collaboration with a number of countries. Interested by the Korean government, the Ministry of Housing and Land and Housing, but the United Nations is also interested on the urban digital twin interoperability, as well as a number of universities in Korea, in Germany, and industries across UK, China, and other countries. So here, the idea here is how to integrate two very different dimensions in a city. One dimension is about the noise pollution, how that noise is actually impacting the buildings, the health of people, and so on. How to use the geospatial standards, which is about the 3D models, as well as combining that with the noise modeling simulation. And the other dimension is about the image processing, how to use the image that is being collected from the mobile camera and so on, how to integrate that to infer some knowledge into that. So these are two different streams, and how to integrate these together. So I focus here, I'm going to focus on the camera imagery, because that is very important from the sense that we are dealing in the digital twin, we are dealing with the structured data, and most of the data is being structured, but we are missing the unstructured data. By unstructured data, I'm talking about the voices, the images, or texts that are being generated, and this is a huge amount of data that we are missing. How we can actually leverage this for our decision making. So with that, what we have done at the University of Central Florida, we focused on the extraction of the location of any images. So some of the images are coming without the location information. This is voluntarily aspect in providing the information, and what we are missing, huge amount of the video recording, or the images are coming without information about the location. So how to synchronize that? And this synchronization is one of the key terms in the digital twin, because the number of the value of synchronization will increase the value of digital twin for real-time analytics and situational awareness. So what we developed here is understanding what is the frame per second, and what is the location accuracy, to be able to adding that to the training data model, which is another standard in the geospatial industry, to be able to extract the information from the images. So put all those images with the information aside, we actually have dealing with the non-informative images or camera recording. So with that, we actually started experimenting in different groups, in different contexts, and it seems that it's very useful for United Nations, where they are actually having some kind of missions across different countries, developing and developed countries. So here the United Nations really wanted to use the low-cost camera imagery and run the image processing to extract all the information about the road network. So we need to check every aspects related to the image, and see if we can actually attribute the location accuracy to the images and the camera recording, and so that we can actually upload that for them and automate the process, so that they don't have any hassle in terms of understanding what is the best image to extract, and how to extract those quality of information. And as you can see here, the UN mission in Colombia, they could actually use this tool that we developed and we provided to them to extract the quality of road networks there. And the same thing is actually useful for any other applications. And here is a collaboration with the city of Altomonte Springs, that we are working with them to understand what is the autonomous vehicles performance in the different urban settings. There is a pilot setting here, crane rides pilot AV analysis that is running around the Altomonte Springs mall, and we actually use the same topic, adding the image segmentation to understand what is the impact of built environment on the AV application, because the AV is actually deployed without preparation in the area. So the area is not designed for the AV, but there is a willing to improve the mobility, and as well as the businesses in the area. So how to do that? But we can actually see that using the image segmentation and understanding the pattern of the design will potentially impact the AV. Here you are seeing that there is a parking here, and immediately doors open for people. So while there are some pedestrian walkways here, you may not see the pedestrian take this area. So this type of design is not really, even for driver car, is a big challenge. So with that, we are moving forward and trying to add the human dimension to that. And as we have heard from Dr. Azevedo, they are looking at the human behavior, and we can actually use their expertise into this and add the human risky behavior and informing the AV through the image processing and also understanding what would be the intention of the human. Even beyond that, I mean, we are looking at the psychological perspective. We can actually look at the physiological perspective from the human pose detection and their intention, understanding of their intention, as well as the complete street design perspective, how this design is actually impacting the human behavior. So we have three dimensions here: the AV as a technology, how the technology is ready for us, the built environment design, how the design like this is actually impacting the human behavior, and what are the human intention for actually using the space. So these three really helps us to move forward to understanding the better design for the future. And at the same time, certainly we are looking at the impact of generative AI, how to actually extract the different design types, the coloring, the pavement, and so on, to be able to inform a better design for quality of life here in this case. And further down the road, certainly we are dealing with again fragmentation of the data. So fragmentation of the data in urban settings, or beyond the urban settings, we are can be addressed in several methods. Right now, we are working on the Bayesian kriging method, for example, for interpolating between the COVID cases across different states and different cities and so on. But this really doesn't help us to move forward through the situational awareness. So our next step here is how to automate the process, while we are having the uncertainty quantification and understanding the level of error in our analysis, how we can actually move forward towards the faster or high frequency level of analysis. Certainly, we will lose some level of fidelity in that, so that the level of accuracy is lost. Now, the question is, what is the trade-off between these two to be able to inform the decision maker? What is the level of frequency that decision maker is looking for to be able to address their challenges? The same thing happens to air pollution, for example. But the air pollution is a three-dimensional phenomenon, where in cities we are dealing with the air pollution in different dimensions, and how we can use the same interpolation method in the three-dimensional, and then add the level of frequency and fidelity to be able to inform the decision makers and even people from the health perspective, because we are dealing with a lot of people who are dealing with the respiratory or challenges from the air pollution perspective. So these are two lines of research. At the same time, we are dealing with natural disasters, other type of natural disasters, and looking for collaboration with mechanical engineers or engineers who are dealing with the fluid dynamic modeling, because this is really useful for us to be able to combine that real-time flood impact analysis on the buildings, infrastructure, and so on. So that is another line of research that we are working on. And finally, we found that most of the analytics, that the real-time analytics in the urban settings, are run through the graph data models. And what we found is those graph data models are not spatial from the geometrical perspective. While they call the spatial because there are coordinate systems, but we cannot rely on that spatial dimension. Our PhD student right now is working on developing the real spatial graph data model. This case is for the utility providers, that we are looking at the subterranean pipeline and helping the water utility providers to understand their assets underground. But this can be used for many other aspects, because we are in the road network. If you look at the road networks, or in the cities, or in the topography and so on, you are dealing with a lot of geometrical dimensions that are really neglected in the previous models and the analysis. So we are trying to address that for the future. And finally, I believe that this type of digital infrastructure is multidimensional, multidisciplinary, and it can be engaging a lot of different disciplines and working together. So my long-term goal is to have this type of infrastructure, digital twin, as a infrastructure for multi-stakeholder collaboration, as a major research infrastructure that can be working across the universities in national and international entities. And based on my huge engagement with the Digital Twin Consortium as an ambassador of academic and research, where there are 200 members in one consortium, I believe that the collaboration across the university and the industry is very important, where I'm really hoping to consider the industry university cooperation research center in the future. And finally, I'm really appreciating my researchers, postdocs, Ph.D. students, and graduate students over the last 1-2 years here in UCF. Although I have a number of them from other universities. I have Nasim, she is from the University of Florida, where I have the privilege of being in her PhD committee, and 2 of my students on the University of Melbourne in Australia. Thank you very much.